Today we're going to look at sending a signal via one port to another port over a connector in Cameo Simulation Toolkit or Cameo Systems Modeler. I'll be doing this in SysML, which means I won't be using the UML interface to type the ports. I will in fact be using interface blocks. However, the basic principles apply equally to UML. Okay, so this is a basic setup. I have an IBD, and we're going to have a keypad. Keypad enables you to dial digits from 0 to 9, which we'll be able to do using the Cameo Simulation Toolkit interface. We'll be able to send signals. It's going to catch each signal and then send each digit via this port. Now, important point. The keypad does not know what it is connected to. The connector belongs to the test context. I'm going to emphasize this again and again during this video. It's an incredibly important point. It's the whole point, one of the main points of using ports. It's a decoupling between the sender and candidate recipients. So one thing we're going to do when we actually run the simulation is show that we can switch from one receiver to another. Okay, so these are sub-blocks of a block receiver. They have unique identifiers, so we'll be able to see which one has in fact received our signal. And finally, just downstream, there is a display object which receives a string. So we'll be sending a wrapped digit as part of a signal here, and a wrapped string on whichever one of these is relevant. Okay, so let's look a little at the block definitions. Let's look first at the interface blocks that will type the port. Okay, so the use of interface block here is truly completely arbitrary. It need not be an interface block. And the ports are not specifically proxy ports or full ports or any such thing. They are just plain ports. In any case, I've used interface block and the SysML 1.6 tilde interface block. If you want to find out how to hack that in the tool, it is easy to do. Find instructions for that online on the Webel site and referenced from this tutorial trail. Now, one subtlety here, you'll notice that on the definition of the signal receptions, you can mark them as provided and required using directed features. It turns out that Cameo Simulation Toolkit does not care, but what you are supposed to do is, if this is going to be the receiving end, then the sending end should be reversed. So that would be required and provided. These just happen to be the other way around by the way it's been constructed. And here are our signals. The wrap digit, we'll have to unmarshal to get at that, and display. Right, so here are our blocks that are communicating in the test context. Keypad, receiver, or more specifically, R1 and R2, which have identifiers, and then display. Display is relatively trivial. And we also have these signals that are just a simple way of being able to send digits from 0 to 9. Okay, so let's look now at the behaviors. So let's start with keypad. All this guy does is run a loop around catching those dialer signals. Here's our dialer signals. There's a 0 behind there, a 1 behind there, and so forth. They are unmarshalled here on an accept event action so that you get the integer out, and that is then fed to send digit via port. Right, so this is where the action happens. Digit comes in. It is fed to the send signal action. The target is set to keypad. That is, the target is the owner of the port. And it has on port defined to be that output port. So let's think about this carefully. If you're doing this with a send signal action and you don't use a port, you are sending to an explicit target on the other side. You are sending straight to something. So the target is in fact the receiver on the other side. If you're doing it via a port, you don't know what the ultimate receiver is going to be. Think about that again. If you're going via a port, you do not know who the ultimate receiver is going to be. Let's just look at the context again. Here's a keypad. Keypad owns that port. The target for sending is not something over here. The target for sending is keypad because it owns the port. We're going to send to the port as the target, or rather owned by that. And then the rest takes place. Keypad doesn't know anything about that connector. It does not know how the port has been connected up. Okay, so those are the behaviors of this sending side. Before we have a look at the receiver behaviors, I just want to show how I'm handling the accumulation of the digits. There's one little complication here that makes the diagnostics much easier. Okay, so here's our receiver. As noted before, it has specializations with identifiers, so we can see which receiver we've hit. It also manages a number object, which in turn manages an ordered list of integers, or as they'll turn out to be, in fact, digits, 0 to 9. It also has some support behaviors. It can append an integer to its list of integers, and you can print the number and get the accumulated digits as a string. That turns out to be very useful if we're sending lots of numbers in and we want to be able to read our progress. Okay, given that, let's look at the receiver behavior. Now, please do not be overwhelmed. There's more going on here than really need to be in the example. I have some diagnostic stuff, that's all. So we'll look at the main parts involving the ports and try to think away some of the other stuff. The main thing to note is that it's receiving a digit here from the iKeypad port. The trigger has a port defined. It is unmarshalling the S digit signal to get at the digit. there is, in fact, if you look carefully, a loop, a bit hard to identify because right around here, to go back to the top so that we can keep receiving digits. The digits are then appended to the accumulated list of integers managed by the number. And once that's done, it then fetches it again as a string. The string is then both sent to the display via the output display port, much as before, just in this case sending a simple string, and the string is also combined here to print the identifier of the receiver so we know which receiver was used. That will become clearer when we run the simulation. Okay, so that's basically quite simple. The append itself is not relevant really for this trail. All we really want to glean from it is that it is adding to a list of integers. That'll do. That's what it does. You can look at the details of that online on the online trail. Okay, now finally we have then the display object. The display is trivial. It reads from its input port, unmarshals, gets the result and prints it. That's all, which we'll see in the Cameo Simulation Toolkit simulation window. Okay, it's time to run the simulation. However, I'm going to try to set it up so we can see what's going on. Now, it does not matter how many times I've tried this, I can never get it to do what I want. What I want it to do is to show, for example, stay here with the context window open, and then with another window open, and have them all open and arranged so we can see exactly what is going on in all windows at the same time. It nevertheless switches around and turns out to be quite hard to do. All right, we launch from the test context, which knows the particular connector. I'll just do that again. Simulation run. Okay, I'll turn the animation speed down. Now, what I'll first do is go through and reach those accept event actions right through the system. So there'll be quite a bit of activity. It's going to load up here all of our end triggers. They are available here under catch end. There's where I can feed numbers in. On the receiver end, I'll see if I can make that larger. On the receiver end, it will sit waiting for something to come in through that port. And when that fires one of those, it should hit send digit via port. Let's give it a go and see how we go. Okay, so I fire. I'll do this nice and slow. I will send a 2. 2 comes to send digit via port. Here's send digit via port. It's a little small to see, but you can see that it's in fact going to send via the port. Here it is. sending via the port. It has now reached into receiver. So we are over here on receiver. That's just setting up the other part. Okay, it's coming to append. It's coming to append. We'll add that on. And down here we'll see there, the receiver has appended. It will now grab it as a string. Okay, so now it's got it as a string. It can send it out through that port. So that has been completed. It prints. So that was R1. So the number 2, display 2. All right, I'll run that through again, this time without fiddling with Windows, just hope it does a bit better. I'll send a 3. I'll speed it up a lot too. Okay, sends a 3. It sends out through the port from the keypad. Out comes through the port into the receiver. The receiver unmarshals the digit, send it to the append. That's just setting up those triggers again. That's nothing, just ignore that. It will then do the append. We are inside the append. The append is happening over there. It will then get the result as a string, send it out through the display port, and has printed the number there, and we've accumulated 2 and 3. All right, so now that the big moment has come, well, I will tempt fate. We saw it here first. Live, change the connector. All right, I have not rerun it. I'm just going to send a different signal. Now remember, this one hasn't accumulated any numbers yet. This one has an accumulator, this has an accumulator. So we'll get a different result. Right, in comes a 4. Sends the digit to the port. The port does not know what it's connected to. The connection context does, and there it goes, to R2. It then, after resetting all of those triggers, comes in here to append. It is doing the append. These traces can be hard to follow when you've gone through them a few times. It will then send it to the display, and we have R2, because when it fetched the ID, it is R2, and I can send another one to R2. I'll make it all very quick. I'll send it a 6. There you go. Send it a 6 or send it a 0. Maybe I had the wrong. I don't know what I sent. I send it an 8. All right. There you go, 8. It's gone straight through. All right, so R2. So you saw it. End of the demonstration. So I'm going to labor this point. A lot of people ask what on earth ports are for. That's one of the main reasons to use a port, because it gives you decoupling of provision of services and information and their consumers. It is the test context that knows how they've been connected up. If you send out via a port, the connector will take it. The connector is known to a higher context, not to the specific port.